Hi, welcome everyone to my talk, I guess, which is titled Conquering Linux. It sounds very exciting. I hope it will be exciting because Linux is very important in enterprise, on the desktop, on mobile, in a lot of places. But the problem is, in the majority of cases, all of the interesting bits of Linux are hidden behind a shiny Chrome GUI. So what we're going to do today is we're going to look underneath the GUI and see what actually happens at the system level and how you can benefit from that, how you can tweak Linux to do whatever you want it to do, and more. It's the system's your oyster. So we're going to follow this basic step. So we're going to use virtual machines. If anybody's not used virtual machines before, it's a way of running another computer on top of your computer. And for the purposes of this demonstration, we're going to be using Arch Linux. It's a Linux distribution. You might have heard of some others like Ubuntu or Fedora. I've chosen Arch because it doesn't do anything for you. It doesn't hold your hands. So we have to do everything manually, which is super great for learning. And then we're going to install it onto our virtual machine and see where we go from there. Okay, so we'll get started. So, a virtual machine. So as I said, it's a way of running other operating systems on your computer. So let's say you're running a Windows machine. You can run Linux. You can run another Windows machine on top. You can run multiple versions of Linux or FreeBSD, anything you want. The advantage of this, especially in the server space, is it lets you segregate resources. So a certain machine gets 20% of your CPU and 2 gigabytes of memory, a bit of hard disk, and you can split up all of the resources. This is how Amazon do their cloud-based services. Same with Google, Microsoft, everyone. But more importantly for us, is it's a place that you can break things, and it doesn't matter, because at the end of the day you can just press delete and your system's back to normal. If you're using virtual machines more extensively, you can use snapshotting, which lets you roll back to a known previous good state. So, the first step you'll have to do is create a virtual machine. So, at this point you've all downloaded and installed VirtualBox. So let's open up VirtualBox and create a virtual machine. So, here's VirtualBox. Everyone got that open? We're going to go, oh god, I've lost my mouse pointer. New. We're going to give it a name because, well, Arch Workshop. Why not? Conveniently, mine's already pre-selected because it noticed I put Arch in the title. Make sure that this is set to Linux, and this is set to Arch Linux 64-bit. 64-bit is important. If it says 32-bit, call a demonstrator. Proceed. 1 gigabyte of memory is more than enough. And we're going to create a new virtual hard disk. Yep, the defaults are all fine. Dynamically allocated, this means it won't use up all of the space immediately. The disk image will grow as you put more data into it. 8 gigabytes, more than enough. As I say, it won't use all 8 gigabytes. That's like a limit on the hard disk. We'll only be going to about 3 gigabytes in this. Once that's all done, you should be at this screen with your new virtual machine that's currently powered off. Now, before we start it up, what we need to do is we need to set up one additional setting. This is important because we're sort of in that weird transition period where we're moving into new technologies. So you might have heard of the BIOS, which runs on older computers. It does the initial setup of hardware. On more modern computers, that's been replaced with a thing called the UEFI. Now, VirtualBox defaults to a BIOS, but for the purposes of learning, we're going to do it the more modern way, which is the UEFI. So we've just got to enable that separately. So for that, we just need to go Settings, then System, onto Motherboard, Enable EFI, Special OSs only. It's fine, we have a Special OS. It's not like Windows. Windows doesn't like this. Cool. So if everyone's done that, you can just click Start on your VM. And it's probably going to ask you for an ISO to boot up, a disk image. At this point, you need to go find the downloaded ISO, the Arch ISO that you've all downloaded. and then we boot up. So, start. God. It's going to say find this. So we're going to click the little folder. There's my Arch Linux. Open. Start. Okay. You can either wait or select the default setting. And it will sit at a black screen. The black screen's normal. This is it booting up. It's an ISO. It takes a long time. Okay, well, now we just have to wait a bit. So every laptop is different. It depends on the speed of your hard disk mainly. Mine's quite slow because it's doing a lot of stuff at the moment. If anybody's got any questions about VMs so far? Yeah?
Can you explain the difference between VMs and containers?
Right. Good question, actually. So, VMs use the technology virtualization. I guess the way of thinking about it is, if you have a system running on the hardware, and you want to run a different system on top of it in some way, you can either go for emulation, which is where you have software which looks at every instruction and decides what to do. So, for example, you can emulate a Game Boy on your PC. So obviously you can't run Game Boy games on your PC, but you can emulate them on your PC, but it's very slow. To mitigate that, they introduce virtualization. And virtualization runs the code directly on your CPU. Oh, mine's booting up. That's good. It is much, much faster. In the best circumstances, it can run near bare metal speeds. But usually the CPU has to have special support for it. So virtualization extensions, which thankfully everyone has enabled, because otherwise it would have failed before now. So mine's already done booting. This is what you'll have when it's finished booting. So that's virtualization. They decided that virtualization is sometimes too heavyweight for a lot of applications. And so instead of running an entire operating system, including a kernel, an entire init system, all of the other applications that run on the system, that you only want to run a single application, but you want to sort of sandbox it from everything else, that's a container. So container runs on your system like a normal program. It's just sandboxed so that it can't interact with the rest of your system. The benefits are it runs quite quickly because it hasn't got any problems. Okay, so we've done that. Everyone can see the prompt, right? Cool. So let's begin. This demonstration, this workshop, is based loosely around the installation guide on the Arch Wiki. If you've never used the Arch Wiki before, it's an awesome resource for anything to do with Linux. Not just Arch, any Linux distribution, Ubuntu, Fedora. If you have a problem with a piece of software, there will be a guide on the Arch Wiki to help you. And surprise, surprise, there's an article about how to install Arch Linux. An operating system's good when it needs a guide to install it. So you can just see the little screenshot here. It takes you through all of the individual steps. We'll be covering them now. If you want to follow along with the Arch Wiki, go ahead. It gives you more information than I'm going to cover. But bear in mind that I've changed a few things, so it's not a one-to-one mapping. Okay. First of all, if you've tried typing anything into your terminal, which is effectively bash, you might notice that some of the special characters are a little bit weird. That's because it defaults to a US keyboard. Now that's not very useful, especially if you're trying to type double quotes, which are on a silly key on a US keyboard. So what we're going to do first is we're just going to tell the system that we want a UK keyboard. So we type load keys UK. And with a bit of luck, yes, I can now type pound signs. That's good. Okay.
So, what if my keyboard is a US layout?
If your keyboard's a US layout, then you don't need to do anything, because you should already have the right layout. Just try a few special characters, make sure they're all in what you expect them to do. Okay, step 2. Installation uses the internet. So let's just test that. If anybody's used the ping command, it's quite a useful testing tool. 8.8.8.8 is Google's DNS servers, so that they tend to work. If this bit doesn't work, you should see replies coming back from the server every second. If it doesn't work, then call a demonstrator. So yeah, mine's working. Apparently I'm 15.6 milliseconds away from Google at the moment. Just go a little bit slower. So on Linux, devices live in a place called /dev. It's a folder on your file system. And hard disks, including things like USBs and SSDs, tend to show up as /dev/sd something, with that something being A, B, C, etc. In our case, we've created an 8 gigabyte hard disk, or maximum 8 gigabyte hard disk, and it's the only one on the system, so we're expecting it to be SDA. Partitions on top of that hard disk, now we haven't got any partitions yet, so we won't see any of this, are, for example, SDA1, which is the first partition, SDA2 for the second partition. So that will come in useful later when we start partitioning our hard drive up. So what we need to do is we need to partition our hard disk. So the hard disk at the moment is just empty space, and the system can't use that. So we need to put some partitions on it. If anybody's ever done partitioning before, it basically involves splitting up your hard disk into sections. We're going to use a tool for that called CG disk. Others are available. You might have used GNU Parted or FDisk. Partition Magic, I think, was an old one made by somebody. It's a long time ago. So to do that, we just type in cgdisk/dev/sda. And you'll probably get a warning telling you something along the lines of, this is a corrupt hard disk. A bit like that. The reason for that is the tool has seen that your hard disk is just full of empty space, and it thinks that you might have a broken hard disk. Now we just created the hard disk, so we're expecting it to be empty space, so we can ignore this warning. We're given this. So the partition layout that we're going to use is, because we're using UEFI, we need a special partition at the beginning called the EFI system partition. It doesn't need to be very big, 256 meg is enough. But it needs to be there, otherwise we can't boot up. And the rest of the space we just want to make one big partition that the system lives in. So, first of all, you can see there's commands that you can select at the bottom with the arrow keys. So we're just going to select new. And it asks you for your first sector. We're just going to accept the defaults for now. So that's the first one we can select. Then it's going to say size. And now we want it to be about 256 meg. So 256 capital M. And it will work out the actual size for you. Now then, the partition type, again, this is the special partition, needs to be EF00. Like that. And as I say, this is the EFI system partition. You just need it. It's part of that. And the partition name, we don't really care. Okay, so we've now got an EFI system partition. Everyone should see that, with a bit of free space before it and about 7 gigabytes free space after it. So press down to select that free space. The second partition that we want to create, so scroll down to use that big block of empty space. Again, we'll create a new partition, accept the default start, and it by default selects the end of the disk, which is 100% the size. So we'll accept that. And the type is fine, Linux file system. And again, we don't care about the name. So you've now got two partitions. Partition 1 is your EFI system partition. Partition 2 is a Linux file system, which is correct. So we just want to write that to the disk. So we select write, and press enter. This may destroy data on your disk. Well, that's kind of the point. Just type in yes. Operation has completed successfully. And then we can quit. Cool. Has everyone done that?
See how it says it may destroy data?
Well, it might not.
What are the conditions for it destroying data or not?
If the partition boundaries lie on some important data that you cared about.
Right. So does it like make an effort to
Not at all. It just overwrites whatever's there. Whatever size you set it to. But the bits inside the partitions it usually leaves alone. Doesn't bother resetting them to 0. Cool. So, that's partitioning done. Next, we need to format it. So the partitions are at the moment just empty space. Again, the system can't quite use that. What we need to do is put a file system on top of it. You might have heard of, for example, Windows uses NTFS, Mac uses HFS+, there's FAT32, if anybody goes back that far, or exFAT, which is used on USB thumb drives a lot. So what we're going to do is, by the UEFI standard, we're forced to use a FAT32 partition for the special partition. So to create that, we use makefs.fat-F32/dev/SDA1. If you remember, the first partition was the special partition, so /dev/SDA1 is that special partition. Yep. Okay, so that first one we just want to be a FAT32 partition. That's required by the specification. Now for the second one, we have a bit of choice. On Linux, a typical file system might be ext4, that's used in production, or XFS. But there are also more modern ones like ZFS and BTRFS. We're going to use BTRFS because it's quite modern, it's fairly stable, won't eat your data much. Sometimes breaks, but for testing purposes it's great. The advantage of using this over other file systems is it has inbuilt integrity protection. It can do RAID, it does checksumming, and it's fairly quick, along with copy on write. So obviously we're trying to format our second partition, so we apply that to /dev/SDA2. So I'll just quickly do that. Okay, that's the first partition. And that's the second partition. So it gives you a bit of information. Hopefully at the bottom you'll see size 7.75 gigabytes. So now that we've got the partitions, we actually need to mount them in the file system. So I'm sort of assuming that you know how the Linux file system works. There's a bunch of directories, everything under /. / is your root file system. And to tell the system that we want another file system, like the ones that we've just created, to be mounted somewhere, is that we literally mount them to a directory. So for the purposes of installation, we're going to mount everything under /mnt, because there's nothing there. It's quite a handy little mount point. In the final system, it becomes our root file system. So this will become our / afterwards. And anything underneath that will be relative to that path. So first step is we need to mount, and remember the primary file system is dev SDA2, because that's the big one, and we want to mount that to /mnt. So we'll do that first.
So if it's the root file system, why do you mount it at /mnt?
Because at the moment the root file system is the one being used for the ISO, so we booted into the ISO. So we're currently running in like a temporary system.
Like a live USB?
Yeah, it's exactly the same principle. When we boot into the real system, then it will become the root file system. But just for installation, we'll put everything under /mnt. So mount /dev/2 to /mnt. Okay, cool. Now we're going to put the special partition, the small one, under /boot. Now remember, everything is on the /mnt. First we need to create the directory, so it's a mount point. So we'll make dir that, make dir /mnt/boot, and then we'll mount /dev/SDA1 to that new directory. Helps I can spell. Okay, so if we quickly look at what's in /mnt, we've got a folder called boot, and inside boot, well, it's empty, there's nothing there at the moment. Cool, well that's the storage bit done. This will be the final file system's layout of our system. So now we need to copy files across. In Arch Linux, there's a handy command to do that. It's called packstrap, and it's a portmanteau of the package manager. If you ever used Ubuntu, you might have used apt or apt-get or aptitude. If you ever used Fedora, it's yum or dnf. Under Arch Linux, it's called pacman. And what we're trying to do here is we're trying to bootstrap a system. So they call the command packstrap. Yeah, bit of humor. So we need to packstrap onto /mnt because that's our destination. And we're going to be installing base, which is just the base system, contains No GUIs or anything. It's just the minimum you need to get a system running. And this will take a while because it needs to download files from the internet. I'll leave that up. Everyone got the installation started? Cool. So I'll just leave that running. As a bit of a game, shout if yours finishes. We'll see whose finishes first. Any more questions about what we've done so far, about partitioning or virtual machines?
So fast, is it?
What does it actually mean to mount a partition?
So it's kind of abstract. Everything under Linux, as I say, was based around directory structures. So it's a hierarchy of directories. You can tell the system that a certain directory isn't actually the files underneath it, but is instead a different file system entirely. I know that that's a really bad explanation. It's a way of linking file systems or hard disks or USB drives into a certain place in your system so you can access it. Under Windows, the analogy is drive letters. So your C drive is your main drive, then D might be a secondary hard disk. But under Linux, everything comes under slash. So you mount to a specific directory under that path.
Do we need to worry about errors and warnings as it throws up?
So right at the end of the process, it might give you a warning about modules. That can be safely ignored. You'll probably see it show up on mine in a moment. Yeah, so it tells you error, file not found, fsck.btrfs. That's the only error you can ignore. If there's any other error, then flag it up. Yeah, it complains again about the same thing. Meantime, I'll explain the next step. So now that we've created these partitions, when the system boots up, it needs to know which partitions it's supposed to be using. For that, the system uses a file called etc FSTab, or FSTab, I guess is the proper name. But it's a listing of every file system that needs to be mounted on boot. In our case, we've got two. We've got the root file system, which obviously needs to be mounted on boot, and we've also got our future /boot, which is the special partition. And we could write that file ourselves. It's not too difficult. But for the purposes of making it a bit quicker, there's a handy command to do that for us, which you can see here, gen FSTab. And if you remember, if anybody came to the bash workshop, this is a append redirection. So we're redirecting the output of the command and we're appending it to that file /mnt/etc/fstab.
What does the -u mean?
I don't know. Should we find out, actually?
I think it means that you just need UUID rather than the.
Let's have a look. Oh, gen fstab -help. Use UUIDs for source identifiers. Yeah. Oh, you know more about. You should be running this workshop. So, for anybody interested in the difference, up until this point we've been referring to the partitions as /dev/sda1, /dev/sda2. Technically, that can change depending on which hard disk gets detected first during boot up. So SDA might become SDB the next time you boot up. To avoid that, we can use unique identifiers, or UUIDs, which are guaranteed to remain the same regardless of what you do. It's a way to prevent issues in the future. To be honest, in this case, we don't really care because we'll only boot up once. And we know that there's only one hard disk. If anybody's interested to see what the file looks like, they can cat it. So that's what my one looks like. Basically, the two non-comment lines say the first partition, so dev SDA2, which is represented by that long UUID, is going to be mounted on /, which is the root file system, so as we expected. It's got a bunch of options as well. And then SDA1, with the shorter UUID, is to be mounted on /boot. So it's just as we expected. So that's the copying of all the files. But if you try and reboot now, you'll be left with a system that you can't log into. So we need to do a final few little bits of tweaking before we can reboot. To do that, the easiest way, we could do it all from here, but it's a little bit clunky. So what we can do is we can actually change root into our new system so that we use its programs and its files, but we don't have a full system that isn't ready yet. And also we're root, so we can do anything we like. The term for that is chroot, or change root. So we're effectively changing where our root directory is. And for that we'll use the command arch-chroot, and obviously since /mnt contains our system, we're chrooting into that. You'll notice that your shell prompt changes a bit when you do this. Because for all intents and purposes, you're now running different programs. You're running the programs in the new system. Again, nothing particularly much there. Cool. First things first, let's set a password. We're setting the password for the root user, which is currently the only accessible user on the system. You can set up more users at a later date if you want to. I'll leave that as a task for the attendee. But we're interested in the root account for now. So to change the password, use the command password. It won't display anything when you're typing the password. That's normal. That's the security of the shell. Just keep typing and press enter when you're done. With a bit of luck, you'll have changed your password. Yep.
So after we change root, does this use the new .bashrc file?
Yes, it does.
That's why it doesn't show colors anymore?
Yeah, exactly that. So we're launching a new bash process inside the system, which has the default bashrc. Cool. Password's done. Now what we need to do is we need to tell the system about a few things specific to a locale. A locale involves time zones, so things like daylight saving time in particular. It's your currencies. It's the way that certain sentences get formatted, the way plurals work. Every dialect is slightly different. For this, we're going to be enabling the British English locale. You can enable more than one. For example, if you expect to write in German at some point, do some typing in German, like translations, then you probably want to enable the German locale as well. On other systems, these are called language packs. So to do that, we need to edit the file /etc/locale.gen. And this is a big long file, so if you need an editor on the command line, nano is a very good one. So for that we just type in nano /etc/locale.gen. That's a very long file. We could scroll down, it is in alphabetical order. There is an easier way to get there, and it's to press Ctrl-W, which is effectively a search. It's a where is. You type in your search. So in this case, we're looking for en_GB. Hit enter, and it finds it. You'll notice there are two entries. One is a UTF-8, so that's Unicode, and the other is an ISO format. Just use Unicode. Don't use ISO, please. Remain compatible. And so what we need to do is we need to delete the comment in front of the line, so the hash symbol, so that it's the uncommented one. When we're done, we press Ctrl-X to exit, and it asks you, do you want to save? Yes. Okay. And now to actually generate the locales, we type in locale-gen. It's a command. This will generate locales for each one that you've enabled in locale.gen.
So if you enable two or more, which one does it switch to?
So we'll be setting the default locale in the next step. At this point in time, we're just telling the system about the locales that we want it to keep track of, in case you want to change it at a later date. So we'll just type in locale-gen. So it's generating locales, waits a moment, and then generation complete. Everyone done that?
Yeah, that's good.
Cool. Locale. Okay, so we've generated the locales. We actually need to tell the system which language it's supposed to be in. defaults to US English. We're going to be using British English. For that, we need to edit etc locale.conf. It's a configuration file rather than a generation file. It's not going to exist by default, so we'll just create it, that's fine. Again, you can use nano to do all of this. And inside, we just want to put one line, and that's lang equals en_gb.utf-8. So that's enabling the locale that we just generated. I'm just going to do it myself. Okay. Cool. Everyone done that? Cool. So that's the language setup. We also need to set up a time zone. The system by default tries to use a UTC time zone, but that doesn't include things like daylight saving time. So what we want to do is we want to set our system to be in the closest time zone to us, which is London. For that, we need to make a symlink. Very straightforward. The symlink that we need to be setting is etc local time. And it needs to be a symlink to something inside zone info. This is how you set the time zones. So ln -s, -s tells it to be a symlink, and the f tells it to overwrite what's there already. And we're symlinking /usr/share/zoneinfo/Europe/London into /etc/local time. Just going to do it myself. Okay. If anybody wants to actually see what the symlink contains, you can ls-l it. So this is mine's now pointing at Europe/London, which is correct. Don't try and read the file, it's all in binary and it will mess up your terminal. We learned that the hard way. So if you try and cat the file, it contains a lot of binary and it will mess up your entire terminal. Okay, cool, that's the time zone set. Next step, remember before we set the keyboard layout, we need to set it permanently. That was only for the current session. To set it permanently, we need to create a new file, etc vconsole.conf. And inside we put keymap equals UK or US if you're using a US keyboard. vconsole stands for virtual console, if anybody's interested. Did I type that correctly? Yeah. Cool. So hopefully next time your system boots up, it's going to have the right keyboard layout by default without having to run load keys again. Okay, now we move on to a big part, which is networking. You may have noticed when you booted into the ISO that the internet just worked immediately. It's configured to do that by default. But the final system won't be configured to do that at all. So we need to tell it to configure the network. So if you run the command, before we do any of this, if you run the command IP space ADDR, this will print out a list of all interfaces on the system, along with which IP addresses they've been assigned. So you'll have an LO interface, which is your loopback. We'll ignore that one. It's for localhost. And then the other one is our virtualized Ethernet adapter, which is the one that we want to configure. So in this case, it's called ENP0S3. On other systems, you might see ETH0 or ETH1. In our case, it's been given an IP address of 10.0.2.15, and that's done internally by VirtualBox. On different networks, obviously, you'll get a different IP address. So what we actually want to do is we want to use systemd to configure our network adapter for us. For that, we create a single file. And the important part here is the name doesn't matter. but it has to end in .network. And you put it in etc systemd network. So for simplicity's sake, we've called it the same as our interface. So you'll want to create, again with nano, etc systemd network enp0s3.network, or whatever you like, .network. And the important bit is that you put these 4 lines in. The first 2 lines, so it's an INI style file, or an INI, name value pairs, key value pairs. So the first section, the match section, we're saying we're going to match on an interface name of enp0s3, which is our interface. And under the network section, we're telling it do DHCP. And DHCP will auto-configure the interface for us from the network. I'm just going to do it myself. Okay. DHCP equals yes. Okay, everyone should have a file with that contents in it. Anyone still typing? Cool. And then what we need to do is we need to enable the services so that they run on boot. At the moment, it's just a file. We need to actually tell the services to do stuff with the file. For that, we use systemctl, which controls the system, and we're enabling 2 services. Systemd network D, which sets our network configuration, and systemd resolve D, which does our DNS resolution. So we type systemctl. Oh, it's at the bottom. Hold on, let me do that. Systemctl enable systemd dash network D systemd dash resolve D. And what it does is it creates a bunch of symlinks which tell the system run these services the next time you start up. Now, networking is quite an interesting topic. Anybody got any questions about it, what we've just done? There's a lot to go wrong with it, in particular. Yep?
If it's set up to run automatically on the oyster, why didn't you just set it up to run automatically?
Because they can't guarantee that doing that is the correct thing. So if you're running an ISO, it's a temporary system, so trying to do auto-configuration probably won't hurt. But on a real system, they can't guarantee that auto-configuration is the right thing to do. In some places, you might want to have a static IP address. In others, you want to make sure that you're trying to authenticate to the network, or you register the machine before it comes online, stuff like that. Okay, we're nearly there. We just need to tell the system how to actually boot. And for that, we use a bootloader. So as I mentioned, the system goes through the hardware and it loads up the BIOS or the UEFI. That's the first step. That's the first bit of software that runs. The BIOS is very stupid. It only really knows one thing, and that's run the code at a particular location. And that's the bootloader. The bootloader is a small program whose only job is to start your operating system. And what it does is it reads a couple of files. It determines which files it needs to load, the kernel and an initial memory image. It loads them respectively, and then starts up the kernel so your OS is now running. That's the job of the bootloader. In our case, we're going to be using systemd's bootloader because it's fairly simple to use. So the first step is using bootctl to actually install the bootloader to our hard disk. So we run bootctl --path equals /boot, because that's the special partition, install. Just going to write myself. And it will say created EFI boot entry Linux boot manager, which is exactly what we want. That says that Linux will now boot. But we now need to configure the bootloader. Lots of configuration. Thankfully there are some sample files, so we don't need to write everything out ourselves. If you run those two copy commands, in this case using tab for autocompletion is super useful. If you just keep pressing tab, it will autocomplete almost everything for you. Copy those files into those locations. So the loader.conf file is the overall configuration for the bootloader. If you want to cat it, you can. It contains one line which effectively tells the bootloader the default entry to load. And in this case it's arch. Conveniently, we've also got an arch.conf, which is the other file we copied in, which defines how to load up Arch Linux. And now we have to edit that because it's not quite right yet. So has everyone copied those files? Cool, I'm just going to quickly copy them myself. Okay, so as I said, bootloader loader.conf just says default arch. Whereas the other one will edit with nano because we need to change a few things. So this is bootloader entries arch.conf. Let's say this is just an example file, which is correct, but it's mostly right. The only bits that we need to change is this options line. And what we need to do is we need to get rid of everything after options and replace it with root equals /dev/sda2 so that we tell it which partition to use during boot up. And also rw, so space rw. That says it's a read-write partition, so we can write to it when we boot it up. Then we just save that as well. And it is a bit bigger so you can actually read it. And we've only really got a last little bit to do. First of all, we need to exit the chroot because we're done in here. We've configured everything that we need to. Like you just type in exit. We need to create one last symlink. We couldn't do this from inside the chroot because of the way that the chroot works, so we'll just do it now. That's just for DNS resolution. Again, -s is for symlink, -f is to overwrite what was there before. Make sure you're putting /mnt at the beginning of this one. Otherwise you'll be overwriting the wrong one. Let me just quickly do that. Oh, I need to exit first. Okay, so as a final step, unmount all the partitions. So those two partitions that we mounted, we want to unmount them before we reboot. This part's not strictly necessary, but it's good to get into the habit of unmounting things when you're finished. So for that you use the umount command.
Why is it good practice to unmount?
Because it prevents data loss. So that the problem is always, if you don't unmount a file system, there could still be cached writes that haven't made it to the disk yet. So if for whatever reason the system were to crash while you're shutting it down, those writes might never make it there, and you'll be left with a corrupt file system. So if you unmount it now, you're guaranteed after the unmount command is finished, everything is safe. You can pull out the hard disk for all it cares, or don't, because it's a virtual machine. But. So umount -R. Capital R tells it to be recursive, so it unmounts everything. Cool. And finally, reboot. Funnily enough, there's a command for that, reboot. So what you see is it shuts down. Now this time we're not booting into the ISO, so it should be a little bit quicker to boot up this time. And you'll be sitting at a login screen. So the username, as I mentioned earlier, is root, and the password is whatever you set the password to. welcome to your new system. You successfully installed Arch. I have a slide for this. Let's just quickly do a couple of tests, make sure we've got the networking correct. So again, we'll try pinging Google's DNS servers because they tend to work. Hopefully that will work with it for everyone. If that works, then that means that your networking is working. And if you can ping google.com or bbc.co.uk or cl.cam.ac.uk, whatever, then that means your DNS resolution is also working. So, yeah, that's working, and that's also working. Brilliant. We're done. The important things to take away from this is it's not just about Arch. All of the techniques that I've shown you here are applicable to any Linux system. In this case, they're mostly revolving around system D, which is a certain, I don't want to call it an init system because it's not just an init system, but it does a lot of other things. It's like the building blocks at the bottom of the system. What we've been doing mostly is configuring system D to do the things that we want for us. And as I say, this is applicable to any system. So even if you see a fancy GUI which says click here to install this program, under the hood it's doing all of this for you. And knowing what it does allows you to tweak it in whatever way you want it to. The system should be serving you, not the other way around. So what can you do from here? Well, probably a good start is to install a GUI so that you can start clicking on things, install a web browser, etc. Here are some examples. It's quite a lot of space though. I don't suggest doing it now because it will take forever to download. You can run a web server if you want to hide this in a cupboard somewhere. You can set up network attached storage. So this is serving files across the network to other machines. Or if you put it on a Raspberry Pi, you can turn it into a media system, connect it up to a TV or an audio system. And that concludes installing Arch Linux. And hopefully making Linux serve you rather than the other way around.